we're going to put together what we've learned to solve the following system of linear equations. So first, we want to build an augmented matrix. So the entries of the matrix come from the coefficients of these variables. So we have variables x, y, z, and w. So my matrix, I'm going to use x, y, z, and w as my entries. Okay, so my coefficients here are 1, 0, -1, 0 is equal to 1. So this line, remember, tells us where that equal sign goes. I have in my next row, I have 0, 1, 2, -1, and this is equal to 3. And in my final row, I have the coefficient of x is 1, the coefficient of y is 2, the coefficient of z is 3, and the coefficient of w is -1. And x plus 2y plus 3z minus w is equal to 7. Next up, we're going to reduce to the reduced row echelon form. Okay. So we start looking at row 1. Our leading entry here is 1. And it's in the first column. It's as far left as possible. We're going to replace row 3 with row 3 minus row 1. Okay, so this is our new row 3. You can see that we've subtracted off the corresponding entry in row 1 to each entry in row 3. And this includes in the augment. So we get 6 from taking 7 minus 1. All right, so row, this first leading entry is done. We have all zeros below it. Now we move on to the next row. Below 1, we have 2. So we're going to replace row 2 with replace row 3 with row 3 minus 2 times row 2. Okay. And just to show doing this out, I'm going to take row 3, which is 0, 2, 4, -1, 6. And I'm going to subtract twice row 2 from this. So that's 0, 2, 4, -2, 6. Okay, so the point of this is just on the side. I want to do this work. So I'm going to subtract the second column from the first one. And I'm left with 0, 0, 0. So -1 minus -2 is 1 and 0. So my final row now is 0, 0, 0, 1, 0. Okay. So now, if I look at my leading entries, they're all equal to 1, and they're moving to the right with all zeros below them. So we're ready for the upward stages now. Okay. So now that this thing is in echelon form, we're ready to put it in reduced row echelon form. We see that all of the leading entries, now called pivots, are equal to 1. So all that remains is to make the non-zero entries above our pivots equal to 0. So we can see that of the potential 3 non-zero entries, already 2 of them are equal to 0. So what we're going to do is we're going to replace row 2 with row 2 plus row 3, or minus negative row 3. And this gives us the following matrix. Notice that if we look at our leading entries, that they are always the only non-zero entry in their column. Okay, so finally, we're ready for step 3, which is to write down the solutions. So we're going to rewrite this thing as a system. So remember, the first column corresponded to x, so our first equation becomes x minus z is equal to 1, because this was corresponded to x, and coefficients of y, and coefficients of z, and coefficients of w. Our second equation here is y plus 2z is equal to 3. And our third equation is w equals 0.